Hello everyone, October 21st. Alright, let's do this. Yep, that's exactly what we had expected. There's number 2. Now it's 10 to the 9th. So yesterday is 10 to the 5, 10 to the 5th. So we are able to go through every single possibility, but now it's 10 to the 9th, so we cannot go through every single possibility. It's going to time out. It's the same problem, right? It's the same problem. We just need a better solution. So yesterday our ideal is we'll sort it, right? And then, because you have a k, right? So we'll try every single one of the possible converging number. And then we will have that one minus k and then plus k. And then we will go through the whole thing, binary search, and then check the length, and then we find the maximum. Now it doesn't work here because we cannot go through every single one of them. And since we do not go through every single one of them, we might miss what should be the solution. So how do we make it better? Now notice the length of the number is still 10 to the 5th. Okay? The length of the number is still 10 to the 5th. It's the value itself gets bigger. Now the value itself gets bigger. I wonder if there is a better way. Now yesterday there was a mention of oh yes, there is a mention of sliding window. That's something that we can try. So again, we have number, right? So number, we can go, a0, a1, a2, an minus 1. So this is the nums. And if we start from a0, we basically have a0 minus k to a0 plus k, right? So this is the range. What we can do is we find where this is, like a0 plus k will be somewhere here, right? And then we'll start from here to somewhere here, so everybody inside is technically within. And then as a0 increases, so we basically shift this thing to the right. But as it is, if we only move a0 a little bit, right? Let's say we are having AP, okay? So it's like to the right of AP, and then we have AP plus 1, right? So basically, if I keep adding a0, we keep, that's already p. I like to say p here, because yesterday we used p here. So we do, what's this? AI, okay, AI, okay, AI. So as p increases, we're moving this sliding window to the right, but it will only move to the right if it accumulates this much. Right, if accumulate this much, yes, I'll move right. Basically, we will get right. So we do the jumps. We don't do the jump one by one. We do like one big jump. And yeah. Basically, this is the starting window, right? This is the starting window. Now we want to ask is if I want to move on to the next one, I need to add this much. Now by adding this much, do we still maintain here, or we will just go forward? Yeah, because if you just increase P a little bit without hitting the next one, then you will not increase. You might even decrease. So we just jump to this one and find out by jumping this much what my left is going to be, and then we'll just move forward until we hit someone that's bigger than it, right? That's bigger or equal to than my, and then that's the new one. So we just sliding window down. Wow, technically we can solve this sliding window as well yesterday, but we didn't really consider that, but it's okay. We'll do it today. So it's going to be sliding window. I wonder if yesterday's hint was like really important for us today. We'll use sliding window, right? Set the target, set the conversion number, sort nums again, then set conversion number to nums 0. Then the max reach is nums 0 plus k. Find out the position, right? Where the position in nums where nums I is smaller or equal to nums 0 plus k. Then we try to expand, right? We try to expand the range to the right, and check how many positions we need to move on the left. This will give us a new range, right? A new range. And also the largest range possible to include, right? To include nums I plus 1, right? Because we want to include this, right? So yeah, this is the largest, and then we say we want to include this. Do we need to move on the left? If we don't need to move on the left, then that's good. But we need to move on the left. It's the maximum, because you can't change, right? So you just keep moving to the right. Yeah. Keep moving the sliding window, right? Keep moving the sliding window until we exhaust. Until the right side reaches the end. Yeah, until the right side reaches the end. The max size of the sliding window is the answer. So we'll do sort, okay, and then int j shall equal to, well, the value is this, 10 to the 9, 2 times 10 to the 9. That's still within though, so it's fine. So j shall equal to upper bound, right? Nums.begin, nums.end, nums 0 plus k. Right, that's an iterator. So we'll do distance nums dot begin to this -1. That's j, right? And then int I is equal to 0. So for j is smaller than nums dot, because that's the size. So once it hits there, that's the end. J plus plus. Right? So every time j need to move forward, we need to check how much more we need to get. Right? So we also need a left bound. So left bound technically, so we have this, we also have left bound. So left bound shall equal to nums 0 minus k. This is the left bound. Right? This is the left bound. So given the current, so it's the j, is the I, so we have the current. So we first do res. So res shall equal to maximum res j minus I plus 1. This is the total length. Yeah, so like everybody inside this is within the range, so you can do this operation, right? And then after we hit it, we should first check on, right, we should say while I is smaller than j, right, because I cannot move beyond j, and nums I, if it's smaller than left bound I plus plus, until it hits something that's smaller, larger, equal to, and then get out. Then we do this. Once we do that, left bound. Then left bound, so we'll move on to the next one. So left bound shall, so we expand plus equal to nums, I'd like to say j, wait, j, so this is the next one, right? So if j is at the last position, so if j is smaller than nums dot size minus 1, then this shall plus equal to nums j plus 1 minus nums j. This is the amount additional. If we move to the next one, that will cause left bound to increase. So we say if we can do that, we'll go for the next one and we check the difference. So left bound has to increase by that much. And then j move forward, right? J move forward, I move forward. And then we'll do this. And at the end, we'll return res. Okay, that's, just try it. Looks okay. Let's submit it. Nope. Num operation 0. Oh, num operation. I did not check num operation. My bad. Num operation. Oh, screw me. Yeah. I forgot to check num operation. Where do I check num operation? Is the res, is the maximum of res and std minimum of num operation, right? And this. Of course, let's start with 1 because you can have at least 1. And this is saying within this range, you can change at most this. Yeah, okay, let's do this again. The second one is wrong. What the hell? Expected 2, but I only got 1. Oh, num operations. Oh, I forgot the same thing. Holy crap. Oh yeah. I forgot one thing. That is the target. Now you don't have target. Shoot. Now what is your target? Target should be, so I move on to here, right? So target is just minus p, minus k. That's your target, right? It's yeah, it's the target is and also j could already be outside. So you really need to get is j. You have to get j minus I plus 1 already. And here, the target, because you need to save the amount. Okay, there is a couple of more things that we need to do. All right, we need a couple more things to do. So we also need an ordered map counter. Yeah, we have to use a counter for int n of nums counter n plus plus. I need a counter. I need to do this, and I have this here, right? So what we need to get is current target, current converging. So converge, right? Converge shall be left bound. No, shall be right bound. Right bound. Oh, right bound. Oh, that's the difficult part. How do you get a right? How do you get a converging number? So j is the one pointing to right. Which means if there exists number such within this, right, such that when I add is the target number, so like we cannot consider, we have to consider some numbers does not need to be operated on, right? Because right now this is not going to be, that's not going to work. We need to know a conversion number. Right, we need to know the conversion number. Conversion number. Conversion number. So now basically I have the range, right? I have the range. I have a left bound, I have a right bound. I have the left bound and I have the right bound. What I want to find is who can be the converging, right? Who can be the converging? So the left bound, basically I have I and j, right? I have I and j. So everyone within this range, I to j, right? Everyone within I to j can be converted by this k into a single number, right? Into a single number. So what we want to find is the maximum within this, the maximum count within this range, right? Maximum count within this range, such that the maximum count within this range, such that the maximum count can be the conversion number, and it can be spared of operation. We can operate on anybody else, but we don't have to operate on this one. How do we find the maximum frequency in a range? The maximum frequency in a range. The maximum frequency in a range. Maximum frequency. Yeah, that's what we want. We want the maximum frequency. We want the maximum frequency in this range. So basically every time we add, we move forward, we add a new frequency, we can get that. And every time we remove, we'll get that. So we can use a priority queue for this. Priority queue. Right, maximum frequency. Okay. So we do need a counter, but we'll function slightly differently. Don't do it this way. We need to get everybody up to j. Okay, we'll get everybody up to j. And then we need a priority queue of pair int. It's like a max, so PQ, all right? It's a max, so it'll be count frequency and number, right? So this is all fine, and we say for int j a p 0, p is smaller or equal to j, p plus plus, right? Then say counter nums p plus plus, and then we need to put everything into pq. So we say for const auto p of counter right, pq dot push p dot first, no, p dot second, p dot first. Okay. All right, so this is that, that's that. And then when we do this, so nums I is smaller than LV, so I need to move forward. So we do counter nums I need to minus minus. Right? So it's minus minus and then I plus plus. Right? And I plus plus, it's fine. And then, yeah. So this is done. We don't have to do this. So we need to find the max frequency of the number in range nums I to j plus 1, right? That number shall serve as the conversion number and can be spared the operation. In other words, we can use the operation on the other numbers, thus boosting the total frequency. Okay, so what I need to know is, we can say while pq.empty, pq is not empty, and pq, actually pq is not empty, const auto frequency and num go to pq dot top. We say if counter num is not equal to frequency, right, then if it's equal to, which means it's a match, then we'll break. Otherwise, pq.pop. Right? Pq, which means counter doesn't match because counter changes but the top doesn't change, so we just pop, 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 pop until we find something that's equal. So now we know, right? Now we know. Now we know the thing that we don't need to. Yeah, so now what we do is we know, we say int converge, right? Converge frequency shall equal to pq.top dot first, right? So what we do is this do not count towards operations. So we can do the number of operations plus pq.top dot first, right? So because those we can still keep, so those are not part of the operation, and then we can add the number of operations. This is the maximum number that we can get, and then we do that, then we get this. Okay, then this one, hold a second, this is just to change the left bound. So now it j plus plus, right? J plus plus. Let me think. So what we do is, hold a second, smaller than j. Okay, so do not count j yet. We will count it in the main loop, the main for loop. So I don't count j here. Right, so I do not count j here. And then we do this. And then here we say counter nums j plus plus. And then pq dot push counter nums j nums j. Right, so this is update because we every time we come the first is when we add a new number. We add a new number, we update its frequency, and then we reduce its frequency, and then we do a bunch of these bull crap, and then at the end, once we're done, we check how much we need to give the next one, and then we do that. Okay, let's try this one. I think this is my last shot. If this still doesn't work, then we will go for something else. Okay, this is stupid. I don't understand why this is not working. So k is 47, right? Oh, I think it's because of this j at the beginning. Because k is 47, initially including both, right? But it's I think with that I can check it to be 0 because this one need to check against the number of operations. Yes. Alright, if it works, then it works. If it doesn't work, we'll have to go through. Okay, well, we have hit some issues. So case 42, we have 2 operations. Right, 2 operations. Why I come out with 1? 2 operations, we'll start from this is 47, right? It's 47, so it doesn't include it. And then oh, 42. So we don't go. Oh, we don't go that much. We go as much as. Okay. So this one I just say move on to the next one. But if I move to the next one, we can miss the previous one. So what I do is I move as much as I can. So like the whole point is to extend as much as we can. So this is the next one. So we want to include the next one, right? So we want to include the next one. So here, yeah, it's the problem is here. I don't know, maybe we change some code. Hold on. So the problem is here. So we want to include the next j, right? Next number. But we also want to do it the most efficient way, which is to add the least amount to left bound such that the next number can be included. The minimum that we need to add to the next bound. So the minimum we need to move. So, but once we hit there, right, and then we can include increase. It doesn't matter because if I increase, it will just. So we just need to move just a little bit. It can be included. So again, so if that's the case, so we can move on to the next one, right? We can move on to the next one. So the left reach of next number shall equal to nums j plus 1 minus k, right? This is the max reach. So what we want to do is to, because j is the max reach right now, so it cannot reach the next one, because if we can, right, then we'll be able to do it already, right? So the reason that it doesn't reach here is whatever it is for the left bound, plus, well, whatever it is, the conversion plus k, and it doesn't reach it. So the next one, right? So the next one can minus, right? Can minus k. We can put a value, right? Put a value. This minus k, and then we shall say. So when that value can be in between, if it's in between, then we only add that much, right? But if it reaches me, what if it reaches me? Reaches the current one. If it reaches the current one, so like we want to add this much, then we can reach the next one, right? Because when I add this much, hold on. Let me think again. We're trying to reach the next one, right? We're trying to reach the next one. And to reach the next one, we need to move the window. We need to shift the window, right? We need to shift the window. But how much the left bound need to move in order to include? So the thing is, I put the left bound at the first one, which is the smallest, and I add k, okay? That does not include. So I need to move, right? So I put the left bound at 5, plus 42, it doesn't include, right? It doesn't include, because it's 5 to 47. But if I move a little bit, which means, so like we are putting at 5, right? This is what we start with. We say that's not the ideal. Ideal should be like the ideal starting point. The left bound should be the ideal left bound. Like this one is something in the middle, right? Because like it should be this one plus 42, so 47, right? So if we have 5 and 64, 47 is the left bound, because this is the maximum value that we can include this, right? Max value that we can include this, and we'll get 47 plus 42. So this is the range, right? So this is the original range that we have for on the right hand side. So on the right hand side, so the left bound is not, so here we say the left bound is this is actually not true, right? It's not true. The left bound should be, but how do we check? No, I hold on. So the left bound always start, yeah, it's fine. Like the left bound starts 5, and that would be the negative whatever, right? Negative whatever, and then so that's the left bound, and then the j will be pointing to 5. Okay, so j will be here, I will be here, right? J will be here, I will be here. Rest is gonna be 0, and then left bound is 5, that's a negative 37, right? Negative 37. So, and then we compute this. And then counter, So j is 0, yeah, okay. And then I is small, no, I is not smaller. And the PQ is not empty. And then it's equal will break. So minimum operation is two operations. The top is 1. So the maximum we can get is 3 operations, but this is a 1, so the currently I got 1, okay? And then now I want to move on to the next one. So I move on to the next one. Right. So when I move on to the next one, I need to add 59. Right? I need to plus 59. So when I plus 59, which is the left bound, plus equal to 59. And then I add a current one. Now I is smaller, so we need to check if it's smaller than 59. But that's not true, right? That's not true. This is the left bound. It should be 59 minus 42. This will give us 17. I think this on both sides. I shouldn't move all the way to it because that's moving too much, right? So I should move just enough so that we can cover it, right? Just enough that we can cover it because we starting from this. Wait, hold a second. My left bound start with negative 37. So negative 37 plus 59 is 22, right? So by moving the whole thing, because I need to add 59 in order to reach, but technically I don't need to add 59 to reach it, right? I just need to add, a minimum so that I can reach that position, okay? No, because I put my right bound to be here. I intentionally put my right bound to be here, right? Because the right bound could be like somewhere in here, so we can include this, right? But if it's somewhere here, yeah, you should do somewhere here. Such that I can include this. Like just how much right bound we need to add such that it can be included. So we'll do this minus k. Now the right bound. Now this should be the max reach. Okay, so this should be the max reach. We say the max reach to be at this position, right? The max reach to be at a position. Can we start with this, right? We start with the smallest, and then we say we add k. So that's the max reach, because if we go smaller, then we shift more to the left. So we say we starting from here, right? We're starting from here, and we have a max reach. So the maximum reach is here, right? This is our conversion number, is the first one, okay? So that's my range. Now I say I want to move. So this is conversion number is this. Because conversion number can be even smaller, but that doesn't make any sense, right? So the conversion number should be this one. But depending on how you view this, like if you go from the conversion number standpoint, then you can say, now let's just say the conversion number is the smallest, right? So we got this whole range, okay? And then I want to move on. Okay, I want to shift. So when you shift, right? When you shift to the right, what I'm saying is the current right bound is some number, right? Some number is the current right bound. The current left bound is the smallest and current right bound. And then the right bound can increase by a certain amount. Then we will include the next one. So I just do that certain amount, right? The right bound, we move that certain amount. And the left bound need to shift that certain amount as well, right? And then we do that. We see if there is any change, right? That's actually the maximum we can. So we're trying to reach the next one, and we see if the left side still get included. Okay, right? And then if that works, right? If that works, then what? Then I will keep shifting to the right, but more I shift to the right, more I go for the right, then the more the left will move until I move to the next one, right? Until I move to the next one. So there is a certain position in between, right? Certain position in between where it's possible to have both included. So that one I can find. And then once I move to the next one, and the left, so now the left is interesting because the left should not, the left should be the left bound minus, right, minus k. Yeah, because the bound is minus and then plus, right? Minus and plus. So that's the total bound. So as I move forward, the left bound. So yeah, in this case, I think left bound is fine. The right bound is not adding 49. Instead, we recognize. So hold on, let me do this one more time, right? So what we have is 5 and 64. Okay, what we say, the first convergent number is 5, which give me the range. Left bound is 37, and the right bound is 47. So this is my initial, right? My initial left bound and right bound. So we do blah blah whatever. So now when we shift to the next one, we need to know the next right bound. So the next right bound should be the next value minus 42. Now the 47 is the max I can reach if it's this, right? So now I need to move forward, right? Move forward. So to reach 64, it's actually gonna take 64 minus 47, which is 17. It takes 17, right? I move 17, then I move here, then I get 64 here, right? This is the right bound, right? The right bound I hit here. Yeah. So the right bound I hit here is 17. So actually on the left hand side, this is minus 20. Right? Minus 20. 5 is still within. That's why it's this. So what I think is wrong, left bound is fine, but I need a right bound. Right bound shall be nums 0 plus k. Right? This is the right bound. Maybe I think this one shall do it here. right? I is 0, we got a left bound and right bound, we find a j, right? We find a j, and then we do these shenanigans, and then we do this and this. This is just like we are adding the current j, because that's when we can move there, right? And then blah blah, this is just fine, this is all fine. And here is what's interesting. So instead of doing this, right, so this shall be this minus right bound. Right, because the right bound initially didn't reach this number, but now I reach this number. So it should be this minus right bound. This is the amount we need to move so that we can reach this one. And then left bound will plus equal to this. And then right bound shall be nums j plus 1. This is when the right bound gets reset. Right bound is reset. Then we go back. And then everything else, I feel like that shall flow. Okay, let's try this one. This is a little bit left bound, right bound thing. Let's put this one in here. Ugh, and then the second one fails. We didn't change much. The only thing we changed is the right bound. Right? I think we change is the right bound. And the left bound shall still be true. Okay, so why this one's wrong? So we have 5, 11, 20, and then 20, right? So operation is 1. K is 5, right? K is 5. So the initial range is 0 to 10, right? 0 to 10 is the initial range. So we shall only get 5 in the first round. And then the second round, the right bound moved to 11, left bound moved to 1. So now I have 2. Right now I have 2. No, because operation is only 1, right? Minimum is 1 plus. That is wrong. Right, this is my current range, 1 to 11, which means with a 6, right? That's, yeah, 6 can give me 1, can give me 11. So if we converge into 6. Oh, I need to still find the convergent number. I need to find a convergent number, which is the difference. So I actually don't need to use this. Yeah, I don't think I need to even use like counter n plus plus. I still need to know the convergent number, right? Convergent number. But hold on. Do we need to use the convergent number? Convergent number. We know what's inside. Right? Hold on. No. The question is, we have these numbers in this range, right? What we want to know is, does any one of those numbers that's in them can be used as the convergent number? Right? That depends on Like, I need to know if any one of those inside can be used as a conversion number. Well, we did land on this, which is the largest, right? This is the largest. So to know if any one in them can be used as the conversion number. So we have I, we have j. So we know what numbers are in them. We also know the right bound is this. Right bound is this. We also know k. So the question is there exist a number that can serve as the conversion number? So to answer that question, I need to know if a number in this because this is the right bound, right? And this is the left bound. This is the left available. This is the right available. So if the left available plus k is larger or equal to this, right? Is larger or equal to this. Yeah, if the left is larger or equal to this, that means every single one of them can be converged to this, which also means we can pick the largest one as the one and everybody else can use the operation, right? So if the left cannot reach j, right? If this cannot reach j, so what I need to know is for j, for the j position, the minus k. So which means in this range, everybody can turn into this. But does everybody can turn into this? Right? Does everybody can turn into this? Because this is a small. So we like the ideal is if this one is possible, perfect. If this is not possible, then we need someone in between. Right? We need someone in between to facilitate. Then who in between should facilitate? So j can minus k. Yeah, so nums j minus k will get the smallest number possible to facilitate. So we'll get some value, right? We'll get some value. We know like they can all reach this, so we'll get some value, call it v. And we can binary search again to see if v exists, right? To do a lower bound on this v. So we get some value, which means that value can definitely reach this, can definitely reach this. It may reach j, it may reach I, right? It may reach this. So just from this one, we just move until, oh, we can do I plus k as well. I plus k. So we get another point, right? So if the other point is here, then everybody in between is capable of reaching both. So we just find the maximum within this. Maybe this is not too much of a thing we can just traverse. What if it's like this? Plus is hitting here. Minus is hitting here, so they don't overlap. That's not possible. That is not possible. They must overlap. If they don't overlap, that means we cannot reach both. So in that case, what I think is we don't need this. We'll do, all right, so this is my last shot. If this doesn't work, we probably have to do something else. So this fine, I think these are all fine. We don't have to do this, we don't have to do this. So we don't do the counter, we don't do any of this. We don't do any of this. This is right? So we have a left bound, we have a right bound. And then we do need to update the counter. Okay, we do need to update the counter. So after this, from I to j, right? So at this point, we can reach. We can reach from nums I to nums j with some convergent number, right? With some convergent number. The question is, can this convergent number be part of nums? If it can, we can save on the operations, right? We can save on the operations, and thus make the frequency even longer, right? Even longer. Make the frequency even bigger. So here is what we do. So we say auto I want it so the reachable from this it1, right? We can say std distance, not distance, let's be lower bound, right? Nums dot begin, nums dot end. It's going to be right bound because we want to reach. Now we want to reach nums j. It doesn't really need to be right bound. As long as it can reach nums j, we're happy, right? So nums j minus k. Right, this is the lower bound, so the one that's larger or equal to this. So this is an auto it2. So this will be a higher upper bound. Right, up bound nums dot begin, nums dot end, nums I, because this is the left. Right, because we can do left, so we want to know which one can reach this, right? Plus k. Right, plus k. But of course, it's it should be minus. This is the one that's larger, right? It should be this one minus 1. So yeah, so what we need to do is go through this range, right, and then find the max frequency. So we can say int max frequency, right? And then we say for auto it equal to it1, it smaller than it2, it plus plus, max frequency shall equal to max frequency counter it. Right, counter it. So this is the max frequency. So max frequency of the numbering nums that can be used, right, has the converging number. So we get a max frequency, and for here, because those can be spelled, so we do max frequency. All right, so if this one doesn't work, we will call it, and then we'll copy and paste, but I still want to continue thinking about this. What the hell? I don't understand. I don't understand. I do not understand. I think you forgot to add max frequency. Yeah, this is actually not right. This is actually not right. Counter should say for int, I don't know, p equal to 0, p smaller than j, p plus plus. Counter nums p plus plus, and then this will be counter nums j plus plus. I don't think it would change, but this is more correct. But now I just want to figure out. So yeah, so we start from here. So it's 5 and 11, right? 5 and 11, and then it doesn't work because I have the range is 1 to 11, and then 11 minus 5 is 6, and then this iteration, it1, will point into here. And then 5 plus 5 is 10, right? So it2 upper bound, and then we point into this as well. So we start from this, but we know smaller than this, so max frequency is 0. I don't have anything. So number of operations is 1, right? Number of operations is 1, but plus nothing. And then this is 2, so now it's 1. Right? So now I'm pointing j is here. So I say left bound should be, so right bound is 11 already. So it'll be this, so it'll be plus 9. Right? Plus 9. So left bound plus 9. So now it's going to be 10 to 20. Right bound. So it's going to be this 10 to 20. So again, this minus 5 is 15, and then 11 plus 5 is 16. So still, this is only 1. Okay, so next it's 0, right? Because this is minus right bound, so 0. So it's still, 10, 20, right? So the range is still 10, 20. 10, 20. And then nums j is going to be this, plus plus, so 20 has 2. And if it's smaller, actually it's not smaller, so it's fine. Right, it's fine. And then, so it's 10 to 20. But the thing is, from 10 to 20, right, from 10 to 20, I have 11, because that's the one when I check. Right, that's the one when I check. Say 11 plus 5 is 16. Right, 11 plus 5 is going to be 16. But the thing is, this is the range, but so 16 lower bound upper bound. Upper bound. Yeah, upper bound 16. Upper bound is pointing to here. And the lower bound, we're pointing to here as well. Right? So we don't get anything. And then we'll get out. But we shouldn't. We shouldn't. Because the left bound can continue. Right? So we just jump out. But we're here. This is the maximum, but we can actually just keep shrinking, right? We keep shrinking. Like, why do we stop shrinking? So if j is equal to, right? If j is equal, so we're already here. So if j is equal to, then let's just shrink on the left bound, right? I shrink the left bound plus equal to, I don't know. Sorry, which is I. So the next thing I can do, I just move it forward, right? Move forward to the to this. The right bound does not change, but left bound will change. And then so what you're saying is, if this, else, left bound shall equal to nums I plus 1. Because j is at the end, so we have I to j, so I might as well just put I forward, right? Put I forward. That's my next left bound. I mean, the more to the right, yeah, because it doesn't really matter. It doesn't really matter. I can just set the left bound to be that one, and then I'll do the same thing. So, but this one has to. So it should be. J is so. So actually, this should be a while loop, right? So it should be a while I smaller than j. I smaller to equal to j. I can be equal to j. And this should be 1. So I smaller than j. And then we do this. So if j's do this, get j plus plus. But otherwise j does not increase. And we got a new left bound, right? Now left bound for 20. And then this the counter okay, then we just move this one down as well, and then we put this as equal to, right? Then we move this, hold on. Right? So now it's 20, I, so we move Okay, let's try this. Yeah, else if I is smaller than nums.size. This is when j hits the end, we continue shrinking on the left bound. Oh, my bad. This is get the next one, so it actually should be in the -1. It's so wrong. Alright, I don't know. Check the answer and we'll copy and paste. But hold on. I think it deserves, but this one is still wrong. I don't know why. I think it deserves some. Okay, so this is wrong. Okay, this is still wrong. Okay, this is still wrong. Need to work on it more. Not sure why, but let's copy and paste this. Wow, we have two things now. Copy and paste. Hey, but the thing is, oh no, we don't need debugger. But the thing is, we have some idea for both of them, right? For this, we have a no, it's not here. We have a solution for that one. It just needs some more work. And this is the same. We'll copy and paste, and in fact, I'm gonna close on these because I'm sure I will never get back to these things, never. But these two, yes, I think I will. But it's a copy and paste. Let's revert this. We'll do it. We'll do it. For sure, we'll do it. And hopefully tomorrow is an easy question, so I can hit this one first, and then we go back to this one. All right. Anyway, that'll be it. I'll see you.